Stone has been used as construction material since prehistoric and ancient times, and thereafter, researching about its mechanism of decay and conservation are vital. The change from rock to cut stone is a substantial one, and it makes the stone, especially its exposed surfaces, very vulnerable to the new environment, and a suitable place for living organisms to develop. This is why the process of stone selection, cutting and finishing is very important for the durability of the stone. For example, placing a stone with the incorrect bedding direction in a facade causes severe deterioration and conservation challenges concerning how to deal with an original defect in a highly significant building. The causes of stone deterioration are chemical alteration, physical alteration, the elaboration process, biodegradation, salt crystallization, thermal movements, and pollution. Concerning chemical transformations in stones, we should distinguish between extrinsic, for example, copper stains, or intrinsic, for example, iron oxides. Stone can present faults, cracks due to the inadequate quarrying, explosives, etc., and craftsmanship, cutting, dressing. Cracks can also be caused by metals insert rusting. As we have mentioned before, soluble salts are a principal agent of decay in porous building materials. Damaging effects are intimately linked with wetting and drying cycles at the stone surface. As the drying evaporation occurs, salts crystallize, producing efflorescence. The most damaging are the hidden salts, cryptofluorescences, occurring in the pores below the masonry surface. Salt decay is more likely in limestone because they contain calcium carbonate, which becomes sulfates in combination with external environment acid compounds. Portland cement used in repointing is another potential source of sulfates. Concerning biodegradation, we have, for example, the biocolonization of green algae. The growth of green algae creates a green patina, more severe in wet periods and locations, turning gray in dry conditions. This gray patina is due to the adaptation of the microorganisms to these severe conditions by the deposition of melanin-based compounds. When they die, become black and more difficult to remove. The presence of moss indicates excess dampness, and it is very important to find the cause. The moss, as well as a symptom of presence of water, it also damages the stone as it secretes acids which deteriorates it. The black patina or black films are black deposits in silicate-based stones such as sandstones and granites. They completely cover the stone. They are probably of biological origin. Dry superficial deposition normally occurs in urban environments. It is the result of atmospheric pollutants such as sulfur dioxide interacting with the stone and the continuous deposition of aerosols onto the stone surface. In carbonate substrates, sulfur dioxide undergoes oxidation and becomes CO3 and CO4, reacting afterwards with calcium-bearing minerals to create gypsum. The crust is created by the deposition of this gypsum in the surface of the stone and its precipitation of gypsum inside the stone, provoking the rupture of the external stone layer. The ICOMOS Stone Glossary illustrates and defines the individual stone pathologies. This glossary should be used for consistency and developed considering also the combination of pathologies present in buildings. Preliminary studies to study the type of stone and its decay include sampling, mineralogical petrographic analysis, and chemical and biological analysis.